Yes, hello, Ali. Assalamu alaikum.
Walaikum salam, sir.
Okay, so yes, how are you? How are you today?
I'm fine, sir. How are you?
I'm good. I'm good. So I was having my iftar and sorry for the delay, right? Let me just.
No problem, sir.
Okay, so in the last class, we talked about uniform acceleration and we saw different cases of uniform acceleration, right? So we saw different equations of motion for uniform acceleration. And we were doing a couple of questions, right? So let's continue with that. But we have to keep in mind that we had this equation whenever acceleration is constant, right? Whenever acceleration is constant, so we have these equations. And then we have last one, which was this, which we found out in the, which we derived in the last class. So these were the four equations, right? Now, if I ask you that, let's do a very simple question, right? So I ask you that the distance traveled by an object is given by the following. Right, so x is, let's say, 4t cube plus 3t square and plus 5t and plus 8. Right, so this is the distance. And then they will ask you that what is the velocity for which or at which acceleration becomes zero. So what is the time and what is the velocity for which at which acceleration is zero? So this is the thing that you have to find out, right? So what we will do in this question, first thing, what we will do? Can you tell me what is the first thing that we will calculate? Yes, what is the first thing that we will calculate? Yes, Alia, what we'll calculate? So distance is given in the parametric form as a function of time it is given, and we have to calculate the velocity at which acceleration becomes zero. Yes, hello, Iram, assalamu alaikum. So we have just started, right? We have just started. Oh, Alia got disconnected. Okay, so we are doing this question, Iram. We have this distance and we want to calculate what is the velocity at which acceleration becomes zero. So this is the thing that we will calculate. So what is the first thing that we will calculate? In the given question, what is the first thing that we will calculate? So this is the important information, right? This is the important information. First, we will calculate the acceleration. So first, we will calculate the acceleration. Acceleration is how much? Acceleration is oh, acceleration is rate of change of velocity. And then we know that what is this v. So first, let us find out what is v, right? So in the sidelines, okay, what is happening to this thing? Okay, what happened here? Okay, so this is not erasing. So let's find out the v first. And what is v? That is dx by dt. So x is given, and can you tell me what is v? Please calculate and tell me what would be v. Yeah, please calculate and tell me what would be v. You have to just differentiate it and then you'll get the answer. Please calculate and tell me what would be v.
0.
V would be 0. So you have this distance, right? You have to put, so you have to differentiate this
Okay.
whole thing. So you have to differentiate this thing. Yes, please differentiate it and then tell me what you will get.
12t square
Absolutely correct. So 12t square and then
plus 6t
60
plus 5.
plus 5, right? So this is the velocity. So velocity we have found out. Now we will calculate the acceleration. Now we have this thing, so we can calculate the acceleration. So let's find out the acceleration. This is d by dt of 12t square plus 60 plus 5. So this differentiation would be how much? 24t plus 6, right?
Yes, sir.
And now in the given question, they are saying that acceleration is 0. So we will put the instant where the acceleration is 0. So this thing is 0. So this is 24t plus 6, right? So t would be how much? So t should be, and see that we are getting a negative quantity. But because I have chosen this random question, time cannot be negative, right? Time cannot be negative, but let's say we get this thing, right? Because I have randomly chosen this form, there could be other form, right? So because you see that x is always increasing, distance is always increasing, right? So your acceleration will not be retardation. So, or your acceleration will not be 0. But yeah, let's say we get this thing. And for this thing, what is time? So this is minus 6 by 24, which is 1 by 4. So minus 1 by 4 we are getting. You will get a proper question, right? This form would be a correct one, right? In which you will get a time which is positive. But for the sake of this question, we are getting a negative thing. That is all right because we have chosen this question, right? So time is this. Now I have the time at which the acceleration becomes 0. So at this time, I can find the velocity. So velocity would be simply 12 into minus 1 by 4 square plus 6 into minus 1 by 4 plus 5. So how much is this thing? So this is 4 into 4, and this is minus 6 by 4 plus 5. So this is 2, this is 3, this is 3 by 4. So LCM is 4. This is 3 minus 2 twos are 4, so 6 and 20. So 23 minus 6. 23 minus 6 is 74 by kilometer per hour. So let's assume that the units are in kilometer per hour. Is it clear? Is this question clear, guys?
Yes, sir.
Yeah, so they will give you some parametric form of distance, and then they will tell you that find the velocity at which acceleration becomes 0. So quickly note this thing down, and then we'll do another questions, right? We have to complete this chapter and start the second one. So we'll do that. Yeah, quickly note this one, and whenever you guys have noted, please let me know. Yes, whenever you guys have calculated or noted, please tell me. Yes, noted, guys.
Yes, sir, noted.
Okay, so now let's do the questions that we were solving, right? So in the last class, we talked about this question, right? 41st, and we will do some simple questions and about is moving described for in first five and 65 in next five is initially last. Yeah, so these ones are good questions. Okay, so we'll do these questions. So only three question we'll take from here, right? So this 42nd one. So this is the question and related with the nth second. So this formula we have to remember. This is how much? This is u plus a by 2, 2n minus 1. So this we have derived, right? And this 42nd question, a body is moving from rest. So u is 0, right? And they are staying from rest under a constant acceleration. So acceleration is constant. We have uniform acceleration. So we can apply these four equations of motion, right? So S1 be the displacement in the first P minus 1 second. So time, case 1 is given. Time is P minus 1, right? So what would be the S at P minus 1? Right, this is SP minus 1 at this time, and this is written as S1, and this would be how much? That would be UT plus half AT square. So how much is this thing? S1 is U is 0, that part is cancelled, plus half, A is constant, and time is, how much is the time? What is the time that they have shown? Time is P minus 1, right? So P minus 1 whole square. So this is S1. S1 is half A P minus 1 whole square. Right. Now case second. What is the second case? They are saying that S2 is the displacement in first P seconds. So now time is P seconds. So SP, that would be given as S2, and this is UT plus half AT square again. So S2 U is 0 and half A and time is p. So this is p square. So S2 is half AP square. Right. So these things we have calculated. What is S1? What is S2? Now we have to find out the displacement in nth second. Nth second we have to find out. Right. So we have to use this thing. So case third. Distance T is now T is, but we are calculating Tth second, right? And that T is how much? That is P square minus P plus 1. So S nth or Tth, what is that? That is U plus A by 2 and 2T minus 1. So U is 0, this part is cancelled, A by 2, and then 2, T is how much? T is P square minus P plus 1, and then minus 1, right? So is this part clear, guys? Is this part clear? Yes, is this thing? Yeah, so we have just put the value of time, right? So STH or whatever that thing is, so that is A by 2. And let's simplify this. So 2P square minus 2P plus 2 minus 1. So how much is this thing? So this is A by 2, 2P square minus 2P plus 1. Right, this is STH. Now we have to relate this thing with these two relations. Right, these are the things that are known to us. So you see that this is P minus 1 whole square. Can I do something about this one and make it P minus 1 whole square? What should I do? Can you guys tell me? What should I do in here that I can use these two relations? What should I do? There is only one trick and that will give you the answer. So can you guys tell me what should I do in this part, in this whole thing, so that I can relate these two things? Remember, A by 2 is there, A by 2 is there. A by 2 is common. So what should I do in this thing? Now I have to solve this one. So what should I do that I get these two things? Any idea, guys? Any idea? Okay, so the simplest idea is that I write 2p square as p square plus p square, right? And then what I do is that I take this one and these three together. So this one as one term, this one as the other term. So a by 2, and I will write this one as one term, and then I will write this thing separately. So this is one term plus p by p square, that is the other term. So this one is the second. This one, these are first term, and this one is the second term. So what I will get? I will write these things separately. And this is p square minus 2p plus 1. So that is p minus 1 whole square. And this is a by 2 p square. So how much is this thing? This is S1 and this one is S. So that would be your STF second. So this would be the answer. Is it clear, guys? Is it clear? Is it clear, guys? Yes.
Yes.
Okay, quickly note it down, and yeah, if you guys have any doubt, please let me know. So quickly note this thing down. Yeah, whenever you guys have noted, please let me know. And we'll do two questions more and then we'll move on to free fall. And from free fall, we'll do two questions and then we'll move on to relative motion and then I'll start the next chapter. Yes, noted, guys.
Sir, just a minute.
Okay, yeah, yeah.
Done, sir.
Done. Okay, so now let's quickly write. So I guess one question I will do and then I will give the other question as your homework. So in these kind of, whenever you have motion in 1D, so you guys should make the proper diagram, right? So from that diagram, you can easily calculate or evaluate your answer. So the concept becomes very clear if you draw the diagram. So let's do this 46th one, right? And then 43rd one, you guys will do. Man is beers accelerating and start running to catch the bus. Oh, 48th one is also an important one. Yeah, so, okay. So 46th one, I will give this question as your homework. 43rd one, but let's do this 46th one first. So a body is moving. A body is moving with uniform acceleration, describes 40 meter in the first 5 seconds. So we have this first journey. This is 40 meters and the time is 5 seconds. Acceleration is, let's say, A, and describes, so let's say initial velocity that is not given. So let's assume it U. And then they are saying that all the things are given. Acceleration is unknown, distance we know, time we know. Uniform or initial velocity we also know. So this is first part from A to B. And then the object or the body covers the second journey. This journey is 65 meters, right? And again, time is 5 seconds. Right. Acceleration is A, and we have to find out the initial velocity. Right. Is it clear? So this diagram makes this question very simple, right? So first I will do is that from A to B, I will use this equation from A to B, right? From A to B, what would be S? What would be S? S would be ut plus half at square, right? S is how much? That is 40. U I don't know, but time I know. Half A I don't know, but time again I know. That is 5 into 5. Right. So let's multiply this 2 with everyone. So we will multiply this 2. So that will become 80. This will become 10U. And this is 25A. Now we can see that 5 is common. So we can take 5 common from everything, right? So this is 16. This is 5 and then this is 2U plus 5A. So 5 and 5 cancels, and I can write 2u plus 5a, that is 16. So this is my first equation. Clear? Now in the second part, what I will use so that I can again use this initial velocity. What journey should I consider? I have used this journey A to B. What is the journey should I consider that I can use this U? Can you guys tell me? Yes. What is the journey?
40 meters.
Yes.
40 meters.
40? Yeah, your voice is very low.
Yes, sir. 40 m.
40 m. So this one we have used already, right? This one we have used already. AB. AB is 40. So we will use the journey from A to C. Right. So from A to C, again, we will use this idea. S is ut plus half at square. And this u is same, right? Because we are covering this journey from here to here. So what is S? Can you guys tell me what is S? What is S? S is how much from A to C? What is the distance from A to C?
40 plus 65.
40 plus 65. So that is 105, right? U is U, that I don't know. Time is how much? Time is from A to C. What is the time? 5 plus 5, that is 10 seconds, right? And then half A and 10 into 10. So this cancels, and what do we have? We have 105, and then this is 10u plus 50a. Again, I can take 5 common, right? I can take 5 common, so this would be 2, and then this is 1, and this is 2u plus 25a. So this one and this one cancels. So what is the equation that I have? 2u and plus 25a equals to 21. So this is the second equation, and now we have linear equation in 2 variables, 2 equation. So we'll just solve these two. This is 2u plus 5a, and this is 16. So subtracting these two, this one will cancel. So I will have 20a equals to 5. So a is 5 by 20, which is 1 by 4. A is 1 by 4 if I put this in here. So putting this value in equation first. So 2u plus 5 by 4, that is 16. So how much is this thing? 2u is 16 minus 5 by 4. So 2u is 64 minus 5 by 4. So 2u is how much is this thing? 59 by 4 into 2. So and then how much is this thing? So u is 59 by 8. That is how much? 7. And do we have that answer? Oh, so okay, we don't have that answer. Yeah, what did we miss in here? So in the first 5 seconds and 65 meter in next 5 seconds, right? So that is 5 seconds. So u is ut plus half at square, right? So that is 25 by 2. And this is 10, and this is 80. So 5, and this is 16, that is correct. This is 2, and that is 5. So 2u plus 5a, that is 16, that is correct. And then we have 105, right? And then 10u plus 50a. So 50a, and then we take, yeah. So why did I write this as 25? So this is 10, right? So this is 10a, and we have 10a. So how much is this thing? Yeah, so this one cancels. This is 5a equals to 5. So a is 1 meter per second square. And we put this value in here. So 2u plus 5, that is 16. So 2u is 16 minus 5, that is right. So 2u is 11. So u is 11 by 2, which is 5.5 meter per second. So this would be the answer. Is it clear, everyone? So one mistake we make, and then the answer is different, right? So is it clear, guys? Only the idea is that we have to make the diagram of the journey. So that simplifies the things a lot. Yes, guys, is it clear? Is it clear? So just make the diagram, and then your answer would become very easy to find. So this is how we do this question. Is it clear, guys?
Yes.
Yeah, quickly note this one down, and then we will do. Traveling with this charges. Yeah, whenever you guys have noted, please tell me.
Done.
Done. Okay, so what I will do is that I will give you guys this next question. You guys please try that one at your home, and we'll discuss. Right, so we will discuss the next question. Yeah, so please take the screenshot of this 43rd one. Please take the screenshot of this one. Right. So this question, take it as your homework. Taken, guys. Yes, done. So take this as your homework, right? Now let's do this question. So a man is 45 meters behind the bus when the bus starts, accelerating from rest with acceleration 2.5 meter per second. With what minimum velocity should the man start running to catch the bus? Oh, so we have to minimize this thing. So this is, yeah, this is not the question related to the NEET exam, right? So this question is different. So yeah, this is all about the uniform acceleration, Right, this is all about uniform acceleration, and now we will talk about free fall. So in free fall, you guys have to remember that there are three kinds of scenarios, right? There are three kinds of scenarios, and what are those? So if you remember this thing, then the question would become easy, right? So in free fall, you have to always remember that what is the only acceleration that you have? What is the acceleration? In free fall, what is the acceleration?
9.8.
9.8, yeah. So acceleration is gravitational acceleration only. In free fall, you have to remember that A is G always. But there is a sign convention. Sign convention, and there are three kinds of scenarios. So three scenarios are there. Right, this is very important. So only the acceleration which is there is G, but we have sign convention. So first scenario is that the object is dropped from some height. Right, object is dropped from some height. So the object is dropping. So in this case, your distance is positive, your velocity is positive, your acceleration is positive, which is G. Right. So whenever the object is dropped, so this is going in the direction of gravity. Gravity pulls towards the surface, right? So this is going in the direction, so all the things are positive. This is one sign convention. Second sign convention is, I will write it in here. So the object is thrown upwards, right? So upward movement. And for upward movement, your H is positive, your V is positive, but acceleration is negative. So this thing you have to remember. These are the two important sign conventions, right? So these are the things that we have to remember, and all the equations are there because this is a constant. 9.8 is a constant value. This is constant. So we will write, we will use all these four equations, right, that we have. So all four equations we will use. That is the idea. And the third scenario is that you have thrown the object, right? So let's say this is some rooftop, and you have thrown the object from here, and then the object is dropping down. So for this scenario, what you write is that your H is positive, or everything is positive, only acceleration is again negative, but you have to use this equation. So your H is, or your Y is, so your Y is Y naught plus ut minus half gt squared. So this is the thing that you have to use. Okay, so let's say that I tell you that what is the time it takes. So if I say that you throw the object with let's say 20 meter per second. You throw the object with 20 meter per second, and this height is, let's say, 10 meters, right? So the rooftop is 10 meters, and I will ask you that what is the time that it reaches this ground. So total time I will have to calculate, right? So one idea is that you can divide this in two parts. One is that going from here to here, and this is upward journey, and from here to here, then you can calculate the two timings and then add them up. But this formula will give you the direct result. right? So this is a very useful relation. And we will do one question about this one. But you guys firstly note down this thing, right? So these three scenarios, you guys note it down, and then we'll do one question which uses this idea. Then it will become very easy to understand. So quickly note down this these three scenarios, and then we'll do some questions on free fall. Yeah, quickly note it down, guys. So at least I want to start projectile motion in today's class, right? So that part I want to start. Yes, noted, guys. So what are y and y naught, right? So y naught is initial position. Y is final position. Yes, noted, guys.
Yes, sir.
Okay, so let's do this question, and this will become very easy to understand, right? So let's do this question which I was talking about. So you have a ball is thrown from the top of the building of height 10 meters with the speed, and let's say 20 meter per second, right? Find the time it takes to reach the ground. Right. So we have to find the time it takes to reach the ground, and these are the things that we know already. So you have this building, and from this building, the ball is thrown. This goes over here, and then it falls. Right. So U is 20 meter per second, and then this height is 10 meters, and this ball reaches here. So you have to find out what is the total time. Right. So we will use, because we are throwing it upwards and then it is falling down. So we will directly use this third relation. Third relation says that y is y naught plus ut minus half gt square. So can you guys tell me? I guess someone got disconnected, right? Oh, okay, Iram got disconnected. So can you tell me, Alia, that what is y naught and what is y in our scenario? What is y naught and what is y? Yes, Alia, please tell me what is y naught and what is y? Yes. So what
0 and
is,
10.
yeah, absolutely correct. So y is 0 and y naught is 10. Right, so initial position, initially it was here. So this is 10 and final position is 0. So we put these values, right? U we already know. So this is 10. This is, this is not 10, but this is 0. And then this is 10 plus ut. U is 20 and t we have to find out minus half. And g is 10 and t square. So this one will cancel. Right, so how much is this thing? So this is 5t square and plus 20t plus 10, that is equal to 0. So we can take 5 common and we can take minus 5 common. So minus 5 common, this is t square minus of 4t and minus of 2, that is equal to 0. So what is the equation? T square minus 4t and minus 2 equal to 0. So this is the equation, right? And now we have to calculate the time. So what would be the time? T is minus b plus minus b square minus 4ac by 2a. So minus of minus 4t, so that is plus 4 plus minus b square, that is 16 minus 4 and ac. So 4 and a is 1, c is minus 2 divided by 2, a is 1. So this is 4 plus minus 16 plus 8 divided by 2. So this is 4 plus minus, how much is this thing? So this is, how much is this thing? Root 24 by 2. So what is this value? So root 24 is 4 into 6. So this is 2 root 6 divided by 2. So 2 we can take common. This would be 2 plus minus root 6. Right. So these are the time that you will right. And you can't have the time which is smaller one. So the correct answer would be 2 plus root 6. Right. So these are the solutions. Is it clear? Yeah. Is this one clear?
Yes, sir.
Okay, so quickly note it down and then we'll do the next question. So please note this one down. And whenever you have noted it down, please tell me. One moment, in the meanwhile, while I just have some water. Yeah, whenever you have noted, please tell me.
Done, sir.
Oh, done already. Okay, good. So now let's do some other question based on this free fall. And yeah, so we have, let me erase these portions quickly. Okay. Yeah, a ball is thrown upward with such a velocity v that it returns to the throw after 3 seconds. Okay, so this one is given. Take g equals to 10 meter per second square, find the value of v. So this one we can do using the direct relation, right? So there are a couple of different questions, but let's do a simple one. And yeah, so let's start with the first one. So a body is released from the top of the tower of height h. It takes t seconds to reach the ground. Where will be the ball after time t by 2 seconds, right? So this is the question. So the ball is dropped, right? This is case first. So case first is that the ball is dropped and it reaches, so this height is h and time is t seconds, right? So then what would be the velocity, right? A body is released from the top of the tower of height h. It takes t seconds to reach the ground. So let's find out what is the relation between this h and t. What is the relation? So we know that h is ut plus half at square, and this is dropping down. So all these things are positive. So this is h. U is 0, so this part is cancelled. A is g, and this is how much? That is 10 and t squared. So this is h is 5t squared, right? So this is the relation. Now case 2. Case 2, and we have to find out where will be the ball after time t by 2 seconds, right? So we are dropping this thing, and now this is the ground, but let's say time is t by 2, right? But we don't know this. Let's say this height is at this point, this height is x. So x is ut plus half at square, and time is different, right? Time is t by 2. So let's put that value. This is 0 and half 10, and this is t by 2 whole square, right? So how much is this thing? This is 5, and this is 5t square by 4, right? So we already know that what is this 5t square? That is h. So h is x would be h by 4. So what is the option that is matching? Can you tell me what is the option which is matching? There is a twist in the option, right? So we have to carefully look at the options. What is the option that is matching? Can you tell me, Alia? Yes. What do you think? What is the correct option? You can write it in the chat box, Alia. Please tell me what is the correct option. Yes, are you there? Oh, you have written in the chat box. So you are saying that option B. Yes, this is the twist. So at h by 4 from the ground, this x we are measuring from the top. From here we are measuring, and this is h by 4. Right, this is h by 4 from the top, not from the ground. So total distance is how much? Total distance is h. This total distance is h. And from here to here, that is h by 4. So from here to here, that would be h minus h by 4. So from ground, this would be h minus h by 4. That is 4h minus h by 4, that is 3h by 4. So this is the option. Is it clear? So there was a twist in the option, right? They have not directly written the correct option, but this was the crucial point from the blue. So is it clear, Alia?
Yes, sir.
Okay, please note it down and then we'll do the, yeah, we'll do one or two questions more and then we'll talk about relative velocity. So whenever you have noted, please tell me. Yeah, whenever you have noted, please tell me.
Done, sir.
Done. Good. So now let us find some other interesting questions. And okay, so a body falling from okay. Okay, so these are the questions, right? At the same time, another ball is thrown upside with a velocity 50 meters per second from the surface of the tower. Then they will meet at which height from the surface of the tower, right? So this thing we have to find out. But yeah, let's do a simpler one. You know what we can do with command droplets. 400 travels in the time of the travel. So what is predicted? Okay, so let's do this question, right? Let's do this 71. This one we'll do, right? And a body is projected with a speed u and the time taken by it to reach the maximum height h. Pick out the correct statement, right? So a body is projected up with a speed u and the time taken by it is t to reach the maximum height. So we have this object, right? This goes at the maximum height. And what is the velocity at maximum height? At maximum height, what is the velocity? Yeah, so when it reaches the maximum height, the velocity becomes 0 because it cannot go any further, right? It will not go any further, so its velocity is 0. And they have given the initial velocity u, time is t, and height is h. Right, so these are the things that they have said. So it reaches h by 2 in t by 2 seconds. So this we will have to check. And it acquires velocity u by 2 in t by 2 seconds. Its velocity is u by 2 at h by 2, same velocity at 2t. Right. So we have to find out we have to find out that what is the height at t by 2 seconds. So at t by 2 seconds. First, let us write all these scenarios. So h is, right, from here h is how much? That is u, and t minus half gt square. So this is h, right? And what is the other relation? So v square minus u square, that is minus of 2gh. So final velocity is 0. So minus u square is minus 2gh. So minus minus cancels, and u square is 2gh. Right. So these are the things that we know. And what is the other thing? So it reaches h by 2 in t by 2 seconds. Okay, what is the other relation? So this is first one. The second one is this one. Third one is that v is u plus at, which is u minus gt. So this is 0, and u minus gt. So u is simply gt. So all these relations we have. This is the third relation. Right. So for h by 2 height, right, let's find out what is the distance. So let's check option A. At time which is t by 2 seconds. Right, what is the distance? So at t by 2, the distance would be how much? So h is, or distance is ut minus half gt square, right? Because it is thrown upwards, and ut is t by 2, right, minus half g and t by 2 whole square. So how much is this thing? This is ut by 2 minus half gt square by 4. That is the thing, right? And we know that what is u, right? What is u? That thing we know. So we can write, or what we can do in here. So we can take 1 by 2 common as well, right? But this would be different, right? So what should we do so that we get a proper relation? So u value we can put, right? U value we can put, and that is gt. So this would be gt square, right? So this is u is gt and t by 2 minus gt square by 8. So this is gt square by 2 minus gt square by 8. So this will be how much? 8 is LCM. This is 4. So 4 gt square minus gt square. So that is 3 gt square by 8. This is one thing. And the other thing is what? So this relation we can also relate. Right, we can combine this first and third relation. So what we will get? So from first and third, what we will get? So h is u, which is gt, and then t minus half gt square. So this is gt square minus gt square by 2. So how much is this thing? So this is gt square by 2. This is h. So I can write gt square as 2h. Right. So if I put this value in here, so this is 3 and this is gt square is 2h. So this is by 8. So this is 3 by 4. So s is at t by 2 time. At t by 2 seconds, this is not h by 2, but that is 3h by 4. Right. So this option is incorrect. This option is incorrect. And we also know that it acquires velocity u by 2 in t by 2 seconds. Okay, so we have to find out what is the velocity in t by 2 seconds. This we can also do. So let's check that option as well. So B option is saying that what is the velocity at t by 2 seconds. So velocity at t by 2 seconds, that would be how much? So we know that v is u minus gt, right? And we know that how much is u value, or what is gt? So gt is u, right? So this would become at right. So we have to find out velocity at t equal to t by 2. So this would be u and minus gt by 2. Right. So this is the thing. And if we put the value of gt value is u. So if we put that, so this would be u by 2. So u minus u by 2 is u by 2. So velocity at t by 2 seconds, that is u by 2. So this is the correct option. Right, this was the correct option. Is it clear? So this was a lengthy question, right? Is this question clear?
Yes, sir.
Yeah, please note this one down, right? So we have to write everything and then we have to compare the result. So in the first option, we had a time and we had to calculate the distance. And we had to find out whether it is h by 2 or not. But we found out that this is 3h by 4. So that was not the option. And in the second part, we had to calculate velocity at t equal to t by 2 second. So this thing we had to find out. So quickly note this one down. And then we will do the relative motion in 1D. So whenever you have noted this thing down, please tell. Yeah, whenever you have noted it down, please tell. So in here, we have used the idea, right? V is u plus at, but we are throwing it upwards. Time is t by 2. So this is minus g and time is t by 2. So you have this relation. I have written it directly. And then we put the value of gt from equation 3rd. Yes. Whenever you have noted, please tell. Yes, noted.
1 minute, sir. Done, sir.
Done. Okay, so now let's move on. So this was about free fall, right? And I believe that you can do some question based on this one. So now, what do we have? Yeah, now let's do some question based on relative motion. Yes, I guess there was some question in here also. Question number. Yeah. So we have this question, and this is related with relative motion, right? And so this is the question. Whenever you have two objects which are moving, right? So what is the relative motion? So relative motion is defined like this. So relative motion in 1D. So let's say we have this one-dimensional path, right? And two cars are moving, right? So let's say they are moving in the same direction, or let's say they are moving in the opposite direction, right? So in these scenarios, whenever two objects are moving simultaneously, then we use the idea of relative motion. So then let's say this is car A, this is car B, and relative motion of A with respect to B, this is simply VA minus VB. So always remember this. And this happens for the two-dimension as well. So this definition is same for the two-dimensional motion, but we are talking about whenever two objects are moving, then you have to apply this relative motion, right? And if they are coming, so if they are moving, there are two scenarios. If they are moving in same direction. So for same direction, magnitude, I'm only writing the magnitude. This would be VA minus VB. So this is only the magnitude, right? And for opposite direction, if they are moving in this direction and this direction. So opposite direction, the speed will become relative speed will become, they will be added together. So whenever the two objects, they are moving in different direction, so the speed will add up. Relative motion will add up, right? So you have to just remember this thing and this thing. No need to note it down because this thing you have to just remember. So whenever they are in the same direction, velocity will appear to decrease. And this you have seen in the example of the train. So let's say two trains are moving, and let's say they are moving in the same direction. So it will appear that the other train is moving slowly. But let's say you are in one train, and in the other train they are moving in the opposite direction. So that will appear to move faster. So it will appear that it is going very fast. It will cross very fast, right? But if that is moving in the same direction, so it will appear that it is moving slowly. So these are the idea of this relative motion. Let's do some question and then this would become clear, right? So we have this question in here. So two particles, right, are 100 meters apart and start approaching each other with constant velocities 2 meters per second and 3 meters per second. The particle will meet after how much time? So they are opposite, they are moving towards each other. So they are moving in the same direction or opposite direction? Yes. Let's say this is VA and this is VB. They are moving in opposite direction. So relative velocity will add up, right? So this would become VA plus VB. So this is 2 plus 3, 5 meters per second. So velocity is 5 meters per second. Distance is 100 meters. So time would be how much? Time is simply VAB divided by D, which is 100 or D by, right? So distance by velocity. So 100 by 5. So that would be 20 seconds. Clear? Is it clear?
Yes, sir.
Okay, so this was a very simple question and you have to use just the idea of relative motion. So whenever the object they are moving in the opposite direction, so this idea is used when you want to calculate how much time it will take to cross the train. So let's say two trains are traveling, right? And let's say they will say that this has length 100 meters. This has 200 meters. This is traveling with 20 meters per second. This is traveling with 30 meters per second. So how much time it will take to cross these two trains, right? So when they will cross each other. So you have to, because they are moving in opposite direction. So you will calculate the overall velocity, that would be 50. And total distance is 100, 200, so 300. So time to cross will be just D by V, which is 300 by 50, which is 6 seconds. So these are the simple question that has been asked using the idea of relative motion in 1D. Okay. Clear? Yeah. So can you tell me that in the above question, what is the distance traveled by this A part or A vehicle? Right, A particle. What is the distance traveled by A particle? Can you tell me? Velocity is 2 meters per second. Time is 20 seconds. Right. So what would be the distance? That would be V into T. So 2 into 20, that would be 40. And for B particle, velocity is 3 meters per second. And time is again 20 seconds. So distance is 3 into 20, which is 60. So B particle covers larger distance because it has a larger velocity. So this covers 60 meters. This covers 40 meters and they both covers 100 meter total distance, right? So when they cover 100 meters, then they will meet. So this was the idea of relative motion. Is it clear? Quickly note this one down. And then we'll move on to the next part, next topic, which is motion in 2D. Yes, whenever you have noted, and if you have any doubt in this one, please tell. Yes, please note it down, and whenever you have noted, please tell.
Done, sir.
Done. Okay, so yeah, these are, and we will also do this relative motion in the motion in 2D as well. But the next topic, so this motion in 1D is over. The next topic is projectile motion, and you have to remember only 3 things. In projectile motion, you have to only remember 3 things. And what are those? So you have to remember that, oh, what is this thing? Okay, this will be not erased. So in projectile motion, you have to remember this thing you have already studied, but we'll do some question in the next class. I will just write down these things. So this is time of flight, right? So the projectile is thrown and how much time it remains in the air, that is called the time of flight. And this is 2u sine theta by g. And then you have this maximum height. So this is the maximum height h. And this is u square sine square theta by 2g. And then we have range, which is this thing. So maximum horizontal distance. And this is u square sine 2 theta by g. So these things you have already learned, right? So we will do some questions based on this. And there is this equation of trajectory also. So this thing we will also talk about in the next class, and we'll do a couple of questions based on these things, right? So you have all these things, right? This one, and this one, and you have to only remember these things. Okay, we'll stop here and we'll continue from here in the next class. So